Role of chemistry in treating polluted water. Water is a precious resource that sustains life on Earth. It is an essential component of our lives, and its availability has a significant impact on our environment and health. However, in recent time, water pollution has become a global challenge threatening human and animal lives, aquatic biodiversity, agricultural production, and economic development. Sewage discharge, agricultural runoff, industrial effluents, and mining activities are among the major sources of water pollution. Lack of access to clean and safe water has led to health problems such as cholera, typhoid, and diarrhea, among others. Furthermore, polluted water affects aquatic life, causing harm to fish, birds, and mammals in rivers, lakes, and oceans. Therefore, the treatment of polluted water has become necessary to ensure that water resources are protected and safe for use by all. Chemistry plays a crucial role in treating polluted water. The use of chemistry in water treatment ranges from the identification of pollutants to the removal of contaminants. The main goal of water treatment is to remove contaminants from water and make it safe for consumption and other uses. In this article, we will explore the role of chemistry in treating polluted water. Identification of pollutants. Before any treatment process can commence, it is essential to identify the pollutants in water. The identification of pollutants requires the use of chemical analysis to determine the composition of water. Chemical analysis is a crucial step as it helps in understanding the nature and extent of contamination in water. The identification of pollutants also helps in selecting the most suitable treatment methods. For instance, if the pollutants are organic, the water treatment process will involve the use of chemicals such as chlorine, ozone, and hydrogen peroxide, among others, to oxidize the organic matter. On the other hand, if the pollutants are inorganic, the treatment process will involve the removal of metals, such as lead, arsenic, and mercury, through adsorption and precipitation. Chemical precipitation. Chemical precipitation is one of the primary methods used in water treatment. The method involves the use of chemicals to remove dissolved and suspended solids from water. The process involves the addition of chemicals, such as aluminum sulfate and ferric chloride, which react with the impurities in water to form precipitates. The precipitates are then separated from the water through sedimentation or filtration. Precipitation is highly effective in the removal of metals, such as lead, copper, and cadmium, from water. The process is also effective in removing phosphates and sulfates, which are major pollutants in wastewater. Coagulation/flocculation. Coagulation and flocculation are chemical treatment processes used to remove impurities in water. The neutralization of the charges leads to the formation of larger particles that can be easily settled or filtered. After coagulation, flocculation is used to bring together the smaller particles to form larger flocks. Flocculation is achieved by stirring the water, which causes the particles to collide and stick together. The flocks are then removed through sedimentation, filtration, or flotation. Coagulation/flocculation is highly effective in removing bacteria, viruses, and other microorganisms from water. Adsorption. Adsorption is a chemical process in which impurities are removed from water through the use of adsorbents. Adsorbents are materials that have a high affinity for impurities and can attract and hold Hem on their surface. Activated carbon is one of the common adsorbents used in water treatment. The activated carbon has a high surface area, which provides numerous sites for impurities to be adsorbed. Adsorption is an effective method for removing organic pollutants, such as pesticides, herbicides, and dyes, from water. It is also effective in removing certain metals, such as mercury, copper, and zinc. Membrane filtration. Membrane filtration is a water treatment method that uses membranes to filter out impurities from water. The membranes are made of various materials such as polyvinylidene fluoride, PVDF, polyethylene, P, and polytetrafluoroethylene, T. Membrane filtration operates under different mechanisms, including reverse osmosis, nanofiltration, ultrafiltration, and microfiltration. Reverse osmosis is highly effective in removing ions, such as sodium, chloride, and nitrate, from water. Nanofiltration is used to remove divalent ions, such as calcium and magnesium, from water. Ultrafiltration is said to remove organic matter and suspended solids from water. Microfiltration is used to remove bacteria and other microorganisms. Membrane filtration is an effective method for removing impurities. Rainwater is widely used in the treatment of seawater and brackish water. Disinfection. Disinfection is a crucial step in water treatment that involves the removal of microorganisms that may cause diseases. Disinfection involves the use of various chemicals, such as chlorine, ozone, and hydrogen peroxide, among others, to kill microorganisms. Chlorination is a widely used method of disinfection in water treatment. Chlorination involves the addition of chlorine to water, which react with microorganisms to kill them. In addition to the use of chemistry in treating polluted water, there are also other strategies that can be implemented to prevent water pollution. Proper waste management practices, such as the SEPA ration of waste, the use of compost and recycling, and the proper disposal of hazardous waste, are effective ways of reducing pollution. It is also essential to prioritize the protection of wetlands, forests, and other natural environments, as these ecosystems regulate the quality and quantity of water resources. Moreover, sustainable agricultural practices, such as the use of organic farming methods and the reduction of the use of agrochemicals, can also reduce pollution. Industries should also adopt eco-free friendly technologies, such as the use of non-toxic chemicals, the recycling of wastewater, and the implementation of green energy solutions, among others. As our world continues to evolve, so do the challenges we face in protecting our water resources. Climate change, population growth, and urbanization are some of the factors that contribute to the gradation of water quality. Therefore, it is necessary to implement new technologies and approaches to water treatment to address emerging contaminants and improve the efficiency of water treatment. Processes. One of the emerging technologies in water treatment is the use of nanotechnology. Nanotechnology involves the use of materials at the nanoscale to perform specific functions. In water treatment, nano Particles are used for various purposes, including adsorption, photocatalysis, and membrane filtration. Nanoparticles have a high surface area, which provides numerous sites for impurities to be adso. Making them highly effective in removing contaminants such as heavy metals and organic pollutants. Photocatalysis involves the use of nanoparticles to catalyze the breakdown of organic compound. Through the use of light, making it an effective method for water treatment. Membranes coated with nanoparticles can enhance their performance in removing contaminants from water. Another emerging technology in water treatment is the use of bioreactors. Bioreactors involve the use of microorganisms, such as bacteria and algae, to treat polluted water. Bioreactors can be used to treat municipal and industrial wastewater, and they have been shown to be effective in removing nutrients and organic pollutants. Moreover, water treatment and conservation raise awareness about the importance of water in our daily lives. Although water covers more than 70% of the Earth's surface, only 2.5% of it is freshwater. And only a small percentage of that is available for human consumption. With the projected increase in global population, coupled with the effects of climate change, water scarcity is becoming a growing concern that affects millions of people worldwide. It is, therefore, essential to conserve water and reduce wastage through sustainable practices such as water reuse, rainwater harvesting, and efficient irrigation. Water reuse is the process of treating wastewater to make it safe for various uses such as irrigation, industrial processes, and toilet flushing. Reusing wastewater reduces the demand for freshwater and conserves water resources. Furthermore, it reduces the discharge of wastewater into the environment, which can lead to pollution and health hazards. Rainwater harvesting involves the collection of rainwater for various uses such as domestic use, irrigation, and groundwater recharge. Rainwater harvesting is an effective way of conserving water resources, especially in areas with low rainfall.